for sticking around. I realize I'm like second to last, and I'm in between you guys and getting more alcohol in your bloodstream at happy hour. So, also, this talk, even though I love getting in the weeds of technical stuff, it's not really a technical talk. So, if you're not technical, or if you are and your brain is dead, you're in the right place. So what I'm going to be talking about is decentralizing security for scale. So just a little bit about OpenDNS. So we were a security startup that was acquired about a year ago by Cisco, and our new brand is now Cisco Umbrella. But I'm not here to give a sales talk. I just want to give you a little bit of info about our environment, because it is relevant. And sorry if I'm looking back a lot. I realize that the slides don't actually show me on here, so I'll turn around and see them. So we do about 90 million DNS requests per day. We do 10 to 100 pushes to prod every day. It kind of varies depending on the day. So there's no real hard security gate in between our developers and pushing to production. So that creates some challenges for us that are maybe unique, maybe not, depending on where you work. Over 300 engineers, which is not a huge number, but again, the significance there is that when we were a startup, we were 10 engineers, and then 50 engineers, and then 100, and we somehow now have got to 300. And the model of having 1 or 2 security engineers for 10 people or for 100 people, it just doesn't scale. When you have 300 people, and we can't hire that many engineers to scale the team. As you all know, it's very hard to find good people in security. And our engineering team is kind of distributed around a few different sites. So DevOps, because I know you guys love all these fancy terms that we like to throw around. What it means to us is that we're moving away from, or we have already moved away from the model where we have an operations team over here that's running the servers, they're running the systems, the software. They're responsible if the thing goes down at night, so they get paged. But they didn't even write that code. They didn't design it. They don't really understand how it works. And over here we have the developers that actually are building things and coming up with things, and when they're happy with it, they throw it over the wall to the operations team, and the operations team is supposed to somehow know how it all works. So you break down that wall, right, and you create teams called DevOps teams. So if I write some software and it goes down, I actually get paged, and it's happened. I've designed systems at OpenDNS that have gone down in the middle of the night, and I got paged and woken up, and I had to respond to it. My team had to respond to it. And you bet, like, after that happens, the next day I come into work and I start focusing on things like high availability or fault tolerance, or let me go and look and learn how auto-scaling groups work. So we know that it works for these other features. Why can't it work for security? And that's what we decided to start thinking about. So I put this up here as like a traditional security monitoring. So we build these rooms, put a bunch of blue lights in them, have like a lot of maps and stuff. And I'm not going to lie, they're pretty cool. Like, it's kind of like a nerd's dream, these rooms. Like, I'd like to work in here just for like a few hours a day. Be like, I feel important. I'm doing cool stuff. And I don't really know who came up with these things. Who came up with the first SOC with all these blue lights. I like to think maybe it's like some former military commander that got into security and said, back in the military we had these tactical operations rooms, war rooms, and it worked there, so why can't it work for security? Why can't it work for the cyber? Let's solve the cyber by creating these rooms and hiring some of the best cybersecurity engineers in America and put them all in a room, and we're going to fix this problem. But it really doesn't work. You can't just try to aggregate things from all over your organization, information, and put it all in one place, and then try to dissect and reverse engineer how all these systems work. And I kind of feel bad for the people that work in these rooms. I know some of you are here today. I've worked in that role as well. This is tough. It's really hard. Like, your job in this room gets harder and harder every single day because you're taking in logs. Maybe it starts out as just a few thousand a day, and then it gets to 100,000 a day, and then you're in the millions, and you're getting events from all over the place, from systems you didn't design, systems you don't understand because you didn't write that code. And you're tasked with finding anomalies. And how do you know what's anomalous if you don't even know what the nominal state of the system is? So this really just doesn't work. So how can we stop complaining about this and get to some solution? So I like to think of there being some walls between these different parts of an organization. So development and organization and operations. This is kind of what we talked about when we talk about DevOps. As a community, we said, hey, we don't like that there's a wall between there. Let's break that down and create what we call DevOps teams. And then we started talking in the security community about development and security engineering. So when I say security engineering, I'm talking about like baking security into the system, doing things like static analysis or doing threat modeling. So people will talk about things like SecDevOps or whatever other fancy terms that I hate, but that's what they title their talks. And I think we've done a good amount of work in that area. We're getting developers to think more about security and how do we write secure code, but I don't think we really talked a lot about this last one, which is how can we break down the wall between development and security monitoring? So how do we get rid of those blue rooms, or maybe keep the blue rooms, but instead of having one giant blue room, let's have one for every team. If you write some code and you're the one responsible for if it goes down at night, and you're responsible for the availability of that, then you understand how it works and how to keep it running. You also should get those alerts when you're getting attacked. Hey, there's some weird SQL queries coming in. Well, I don't know if those are anomalous or not, but the team that wrote the product, they could tell you right away whether that looks normal or not. So why not let them do that work? So I put this up here, and it's maybe a little bit of a misnomer, but so what I'm saying is most small engineering organizations don't usually have things like performance teams, scalability teams, and availability teams. Now I know that there's people in this room that work on teams like this, so I'm lying a little bit, but in general, a lot of companies don't have these things. So if we don't have those things, why do we have security teams? So let's step back for a second and assume that we do have these teams. So let's take performance engineers, for example. So one thing performance engineers don't usually do is like go running around the organization trying to convince everyone that you need to write fast code. You need to write it now. It's really important if you don't write fast code. They also don't write unit tests for code that they didn't write. Doesn't make any sense. Why would you do that? And they don't aggregate logs from 1,000 different components all into one place and then spend just like tons of resources doing things like data science and ML so that we can try to like find that one needle in the haystack anomaly. For all these things that really you could probably go walk up to the teams that are writing these products and say like, hey, this thing looks weird. Is it weird? And they might be like, no, that's totally normal. But that other thing over there that looks normal to you, that's actually really weird. But we do all of these things in security for some reason. I don't know why. But it doesn't have to be that way. So, product teams understand their product better than everyone else. We said that. And if we decentralize security monitoring, we get another benefit too. We can eliminate this back and forth politics and communications that we have in our organizations between groups, right? How many times you guys work on security teams have you had to try and convince someone that this security of fixing security was important? Or you had to escalate it up the chain and get a VP involved. This is so important, we need to get it fixed. It seems like the developers don't care about security. That's what it seems like from our perspective. But I think when you really start talking back and forth and you have that communication and you don't have this barrier, you realize that's not really the case. People do care about security, they just don't really know where to start. If you tell someone, hey, go secure that thing, where do I even start? If you are someone who works on like a red team or you're a pen tester and you've attacked things, do you really know how to fix those things? Some people are great at doing both. But a lot of times I've seen people say, hey, I broke your thing. I found an XSS. And then they say, okay, help me fix it. And they're, oh, I don't know. I haven't used that language before. So we need to get those people working, get everyone working together more. And I think we can get the benefits we saw from DevOps over in this new model with security as well. So what we saw with DevOps is if teams own the full stack of their product, then they're more responsible and they're going to build things that are more reliable because frankly they don't want to get paged for the thing going down. So if you also say that, hey, security is also your responsibility, then you can be pretty sure that people are going to start thinking about security and they're going to come after you to ask, hey, how do I secure this? And I think we saw this in our organization. When we started pushing this down, and promoting this model, we changed from a mode where the security team was going after each dev team and poking at them and saying, hey, security is important. What are you doing there? Let us scan your stuff. We moved from that to the teams are actually coming after us and saying, hey, we want to do threat modeling. Hey, we want to know how do we fix this this particular vulnerability that this scanner says we have. What's the best way to fix it? And that was pretty awesome. That was kind of exciting for me to not have to be the bad guy and instead actually be someone that can help. So the security team is not responsible for security, and that's kind of like the model we're trying to adapt at OpenDNS. And every team is responsible for their own security. So that's nice and easy to say, but I'm sure that if you all went back to your companies or wherever you spend your time tomorrow and you said, hey, we're not responsible for security, Chris said, your CISOs might not be so happy. So there's two things. So one thing is this really does have to get support from the top. Like the upper level directors, managements, and C-levels and all that, they need to like be on board with this. That engineering teams are responsible for security as a part of what they're building, just like availability is, just like performance is. You know, engineers don't usually say like, I don't care if my code's not fast, that's the performance team's job. But I hear people say that for security, like, I don't know about security, like the security team will handle it. So that's one thing. That needs to like come down from the top. And then the second thing is that the security team then needs to start shifting focus. So I'm not saying you shouldn't have security teams and that we all should just stop showing up to work. But what I am saying is that we need to shift what we spend our time doing. So instead of doing manual triaging and processing and trying to scan things and find who owns this asset that I scanned that it had a high criticality vulnerability, we should leave that to the teams and let them do it. And in order to let them do it, that means we need to spend more time on development, developing security tools, doing education to an extent, but I worry a little bit to say that word because I think we need to make it extremely easy for developers to use. Things like if you're running Jenkins to do CI, for example, a lot of development teams will run things like linters, right? Oh, I want to run this linter to make sure that my Python code is really pretty and follows a standard, so I'll run like pep8. Well, why not just run something like Bandit in there as well, right in your job? I think if you see those things coming in, you're going to want to fix them. It's kind of like a gamification of sorts. Okay, so enough preaching that idea. So I just want to talk about two of the tools that we're hacking on that I think are kind of going in that direction of empowering developers to do security or to take on security. In very early stages with this. So really, really interested to get feedback afterward and find me and we'll chat. But the principles here are that they need to easily fit into the current team's workflows. So we can't build some tool that's going to require them to spend a lot of effort to get started or else they're just not going to want to do it. So find what they're already using, like maybe you use GitHub inside or maybe you use Jenkins. Integrate it in with those things. I mean, even if you don't like them very much, it doesn't matter. Like just integrate it in what's going to be the easiest solution for the developers. No reinventing the wheel. We don't want to like write, yet another secrets management tool or yet another name your tool, right? We want to just use the stuff that's already out there. If there's really something not there, we can write it and open source it. But the open source community is amazing. Like, let's take advantage of that and let's just write just enough code to integrate it in with our workflow at our companies to make it easy. It should be automated. We're huge on automation, on APIs. If we have to click a button, we get really mad. So make it automated, make it easy. Don't like make someone have to manually do something. And stupid simple. So a developer shouldn't have to think about like, I'm going to get this SSL cert. Which cipher should I use? Should I use ECC? I heard that was kind of a cool thing up and coming. Like, no. You shouldn't have to think about any of that. Just click a button or don't click a button. Call an API. And you'll get a cert. So I'll talk about two tools. So the first tool is called Starboard. Again, like extremely simple, this thing. It's not fancy at all. What we were looking for was just a way to do very, very simple port scanning. So as we were moving from the model of rack and stack hardware data center that we had for years and years, and we were moving more into the cloud. Of course, we're in AWS. Of course, we're doing Docker, all these things. Of course, that model of that central firewall where a security team manages the ACLs just doesn't work anymore. Right? Developers themselves are writing security groups around AWS EC2 instances. Developers themselves are writing in Docker. We have a Docker hosting platform that has its own little firewall thing for each container. The developers are writing that. They can expose things to the internet. There's no sign-off. And so how can they monitor that things look like the way they want them to look? And so we wrote this super simple thing. Basically, you can spin up these little Nmap scanners that do port scans at different perspectives in your network. And I made a really simple, even more simple example here, which was, let's say I just have something and I want to know what ports can I access from inside my network and what ports from outside. And then it compares those things to a baseline. So the developers themselves write a little baseline in YAML. And if anything is different, that goes into Nagios, because Nagios is what we're all using for how many decades? There's still nothing better. But that's what we rely on for monitoring. So if it builds into their workflow today. So anyway, if something changes, that'll turn red in Nagios, and if it's a bad enough thing, it'll send out a PagerDuty. So teams are using this, and teams are learning things about the things that they've built that they didn't even know. Like, oh, I didn't even realize that port was open, and it was only internal, so that's good, but still, why is that open? Yeah, that's that. So the next tool that we're working on is trying to make SSL certs like what I'm calling dead simple. So we, for a long time, and still in many cases, had this very manual process that I'm sure a lot of people have, where the developers are having to figure out how to create a key, and then how do I create this CSR thing, and then let me Google for the commands and copy and paste them, and then I have to somehow upload my CSR to this CA, and it's very, very complicated. We started using a tool from Netflix called Lemur, which is really awesome, by the way, and that helped us move forward quite a bit. So developers instead were going to that tool, and they were requesting certs from there, and then that thing kind of does the magic for them. But we wanted to make it like even easier. How can we make it even easier? So what we're building is this thing called VINs, and basically you call this API and you say, hey, I want to cert with these domains. In this case, I just have like these two, store.opendns and store.umbrella. And what it will do is, in the back end, it will say, okay, was this a publicly facing cert, or does it need to be publicly trusted or not? And if it's publicly trusted, then it'll go to Let's Encrypt and it'll get it, and it's free. Let's Encrypt is awesome. It'll put the key in Vault, and we have these other options there too. So there's a limit to how many certs you can get with Let's Encrypt. I think it's like 20 per week per org. So if we hit that limit, then we fail over to DigiCert, and then we'll pay for it. But hopefully that limit will go up if Let's Encrypt people are listening. Please raise the limits. And then if there's something internal, we actually haven't implemented this yet, but we're doing that soon. Then we'll hit our internal CA and get an internal cert, because we do a lot of things like container-to-container communication, or anything that we want to use client-side certs for. But this still wasn't easy enough, because then the developers now get the cert and they get the pointer to the key in Vault, but then they have to figure out how to deploy from Vault, which isn't that hard, but why not make it even easier? So we have this thing called Quadra, which is a container platform, which is kind of like Kubernetes. So we started working on this thing like before Kubernetes was released, so that's why we're not using that. But we deploy most of our things onto Quadra now. So we thought, how can we integrate it with Quadra so they can just have one-stop shop? So basically now what happens is developers can go right to Quadra when they're deploying their containers. And there's a special type of container in Quadra that we have. It's just a simple load balancer. And previously you would have had to take all the cert material and give it to it as a pointer to our secret storage. So it would download it. But it was still kind of clunky. So this way now you can say, hey, I want a load balancer, and I want it to support SSL, and these are the two domains that I'm going to be running on that load balancer. And so Quadra says, okay, cool. And it goes and it talks to this VIN service, and it gets the cert for you, and it puts it in the load balancer. And when it starts getting close to expiration, it'll bring up a new one with a new cert, move the traffic over, and destroy the other thing. So basically, developers don't have to know anything at all about SSL certs, which is really awesome because of how many problems they cause when they expire. And that's pretty much it. So honestly, guys, I really just want to like kick off like a discussion, like not here right now, but when I go down. If you have questions or if you have ideas, I really want to like know if you guys are thinking around like the same path, and if you've done some of this stuff already. I'd love to learn more about what works and what doesn't work, because I know this is for us kind of a new idea, and you might say, hey, that doesn't work, Chris. I'm sorry to tell you, we tried it 5 years ago. But just find me in chat. Thanks.
On behalf of Fitbit and BSidesSF, thank you, Chris. Another round of applause for him.